Well, good morning, y'all, or good afternoon, whenever you're watching this. Hope y'all are doing well. If you would take out your own paper, and you'll need to pause the video in just a moment, but title this unit 4.1-2 Angles and Lines. And if you'd write down the names here of these various angles, because I'm going to sketch them out to the side one by one. So go ahead and pause your video, get these things written down, and then we'll begin. Okay, some of these you've had before, but I first want to draw what's called supplementary angles. And supplementary angles always form a straight line. So we'll call this angle A degrees, B degrees. Now that little circle stands for degrees. It's not an O and it's not an exponent of 0. It just stands for degrees. Now while we're on it, angle B is an acute angle. It's less than 90 degrees. Angle A would be obtuse. It's greater than 90. And the combination of A and B is 180 degrees, and we call that pair supplementary. We also call this a straight angle. That's the little symbol for angle. The bottom is flat, and then you've got a curve like that. There's one other thing, two other things I'd like you to know about this. This is also called a linear pair. Now that's a really important term because we use that a lot in geometry. The fact that they are supplementary, that it has to be the case, they have to form, the base is the same, and they're right next to each other. And because they are adjacent, we also call those adjacent angles. So just in this little setup, there's a lot of information. So let's, what I'd like you to think in terms of is the fact that that's a straight angle, and you've got two angles combined to make it that way, so that means it's a linear pair, and they always equal 180 degrees. So we've done linear pair, we've done adjacent. Okay, let's do complementary. Many of you can probably guess what that is. You've had that before, I'm sure. If supplementary is 180 degrees, complementary angles and we'll call that angle A and angle B. Complementary angles form a 90-degree pair. But right now, even though it looks like a right angle here, we cannot prove it so until you put this little box here. Now we know it's a right angle, so angle A plus angle B equals 90 degrees. They're complementary. So if, for instance, angle A was 60 degrees, we would absolutely know that angle B had to be 30, because 60 plus 30 is 90. Now, what else can we say about these? These are also adjacent. They are next to each other. They have a common side that they share. Are they also a linear pair? Does it have a base that's a straight line? No. They're not a linear pair because a linear pair would have to be 180 degrees. So these are complementary, they're also adjacent. Now, the truth is, in our level of geometry, we don't deal a whole lot with complementary angles. We deal a lot with supplementary. And then there's one other type that's very common, and it's very easy to recognize. See, we dealt with complementary. Now we're going to talk about vertical angles. Vertical angles always form an X. They always form an X. And what's cool about this is that with vertical angles, the ones across from each other are always congruent. So if A was 25 degrees, B would have to be 25 degrees. So let's label these as vertical angles. And they are always congruent. Congruent means same size, same shape. Now you might guess, what about angle C and angle D? Are they also vertical angles? Sure they are. They also form an X. So let's say that this was 70 degrees. D would also have to be 70. And looky here, guys. Do you see that angles B and C form a linear pair? They form a straight line, which means they're 180. So for instance, if we said angle C was, I don't know, 60 degrees. No, that's wrong. I've done it backwards. If we said angle B was 60, C would be 180 minus 60, or 120 degrees. And that will be, that'll come in handy very shortly. All right, so let's go to a couple examples here. All right, in example one, and you know, I know you'll have to pause the video, write down this sketch. Incidentally, this is 209 degrees, 54 degrees, and that's B degrees. We're trying to find this angle right here. Well, you probably know from other math that all the way around a circle is 360 degrees. So you've got 360 degrees all the way across, all the way around. All right, well, this 360 is made up of 209 degrees plus B degrees plus 54 degrees. And so I'm assuming that already you can figure out how to do this. Let me get my calculator out and my glasses so I can see what I'm doing. So I'm first going to add 209 and 54. All right, 209 plus 54. Now you may remember when we were doing trig, you had to go to the mode and change it to degree mode. The default is radian, and if you want to check, you'll see that it is. You don't have to go back. So far we've got that 360 degrees is equal a total of 263 degrees plus angle B. And so we'll just subtract 263 degrees from 360, and we get 97 degrees. All right, that should make pretty good sense. All right, let's go on to number 2. Okay, here we're trying to find angle X, and so you have to say, well, okay, what do we know about this situation? Well, hopefully you'll notice that this forms a straight line. In other words, this is a linear pair, and we know that linear pairs add up to be 180 degrees. So that's how we'll start. We'll say 180 degrees equals the 3x plus 12 plus the 96. And so we get 180 degrees is equal to 3x plus, let's see, that's going to be 8, 10 plus 108. And we'll subtract 108 from both sides, and that would give us 72 over here. I hope I'm doing this right. And then we'll divide both sides by 3, and let's see, 3 goes into 7 twice, so that's going to be 24 equals X. Now, notice the 24 is not a degree. It's just the value of x. The 3 times 24 plus 12 gives you that angle. Okay? All right, let's go on to number 3. Similarly, in number 3, we're trying to find the value of x. X itself is not the angle. It's 14 plus x is the angle. Well, the clue is right here. If that's a 90 degree, then that also has to be 90 degree there. So in other words, these two are complementary. We know that 14 plus x plus 57 equals 90 degrees. And let me get my calculator to make sure I'm doing this right. Clear that out. All right, so I got 14 plus 57 is 71. So we have x plus 71 equals 90. Now we'll subtract 71 from both sides and we get 19. So the value of x would be 19. So if we wanted to find this angle here, and that's the symbol we use for an angle, we'd add 14 plus 19 and we'd get, what, 23? 33. Yeah, 33. All right, let's go on to the next one. I think we have 6 problems in all to do here. Okay, here's something new. We have what is called an angle bisector. This is the bisector. It splits this angle into 2 equal angles. The official word is congruent. And that little symbol is the same as that little symbol, which means this angle is the same as that. So if this angle is 20 degrees, that angle would be 20 degrees. That's the nature of a bisector. It cuts it right in half. So what we're trying to find over here is the measure. That's what that means, the measure of angle 2. Okay, well, hopefully you're thinking, all right, if we find out what angle 1 is, we know it's going to be equal to angle 2, don't we? Well, let's see what other information we've got. We're told that the measure of angle 1 is 7x minus 2, and the measure of angle 2 is 6x plus 1. Well, let's see. Would it not be true that if that's angle 1 and that's angle 2, and we know they're congruent because it's been bisected, these two would equal each other, right? So we're going to say that first angle, 7x minus 2, has to equal this other angle because they're congruent. And then we just do the little bit of algebra. We'll subtract 6x from both sides. And then we'll add 2 to both sides. So we've got that x is equal to 3. But are we done? No, they want to find the measure of angle 2. Well, we'll take that 3 and put it right there. So 6 times 3 plus 1, that's going to be equal to 19. So if we wanted to, then we would know that angle 1 also has to be 19. And if they wanted what angle Q is, the whole thing, we would add 19 plus 19, and we would get 38. But in this case, they just wanted the measure of angle 2. So you solve for x and plugged it in. Okay, number 5. Got a new word here. It says that points A, B, and C are collinear. Well, what does collinear mean? Well, it means they're all on the same line. So let's just draw a line. Always draw sketches in geometry if you can. B is somewhere in here between the two. It's not necessarily in the middle. And so what are they asking? We're trying to find AC. All right, so let's indicate that. When we're all done, we're trying to find this whole length from A to C. We know that B to C is equal to 5, and A to B is equal to 12. Now, I normally don't draw this, but I want you to be able to see this. So I think at this point you should definitely figure out if from here to here is 12 and from here to here is 5, if we want the whole thing, it's going to be 12 plus 5. So 12 plus 5 is going to be AC, and so that's going to be 17. Yeah, pretty straightforward, but it helps a ton to draw out the sketch. All right, last one. All right, same deal. We've got A, B, and C are collinear. I was too lazy to write down the directions. All right, so we've got A, let's put B right here. I don't know where it is, but we'll call that C. Now, let's write down the information. What we're trying to find is we want the length of B to C. So we want to know from here to here how far that is. Well, what information do we know? Well, we know that from A to B is 2x minus 13. So in other words, from here to here is 2x minus 13 units. And they tell us that from A to C is 8 units. So at this point, I hope that you can already sense how we're going to do this. We're going to take the whole length, 8 units, subtract from it this piece, and that will leave us B to C. So if you want to write it this way, we would say that 8 is equal to AB plus BC. Or in other words, from A to B we know is 2x minus 13 plus BC. Now I'm going to put a line over BC because that's typically the symbol for line segment, and that's what we're dealing with here. So let's, wait, have I messed up here? Oh, yeah, yes, I have messed up. I was thinking this is not making sense. I left off what B to C is. All right, I got to go in a whole wrong direction. Well, B to C is negative 9 plus x. All right, so we're not going to be subtracting at all. In fact, I need to erase that. Sorry about this, guys. Now this is still true. 8 is equal to that plus that, and that's going to help us solve for x. So we've got 8 is equal to 2x minus 13 plus negative 9 plus x. So let's combine the like terms. We have 2x plus 1x, so that's going to be 3x. And we have negative 13 plus negative 9 is going to be negative 22. So we'll add 22 to both sides. And I'm going to come over here because I'm out of room there. So 8 plus 22 is 30, so we have 30 is equal to 3x. Divide both sides by 3, so x is equal to 10. But remember, we're trying to find B to C. Well, B to C is equal to negative 9 plus x, or in other words, negative 9 plus 10, or in other words, B to C is equal to 1 unit. Okay, well, that's it on this unit. And y'all will have a paper quiz to do. If I remember right, there's 6 problems on it. As always, I need to see the work, take a photo of it, and upload it to Canvas. See you guys.